good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubinda with another video. So we are continuing on addition mathematics, calculus. This is differentiation. Now looking at the second differential coefficient. That is a subtopic which is there's a d power 2y, then a dx power 2. The way you pronounce this, you say d2y, dx2, the second derivative. So maybe you can be given a function, for example. Let me say y, okay? The example is y is equal to f of x, like that. So to find the derivative of a function like this, a function given by y is equal to f of x, we would say f prime of x. So we would put a power 1 there. It is different from saying f inverse of x. This means we are finding the inverse function, but here we are finding the derivative. This is another representation of dy dx. So we can say f prime of x or dy dx is equal to something. So this and this are the same. They mean the same thing. Okay, now the second derivative, the second differential coefficient, means we are taking two derivatives. So this power 1 like that means the first derivative, and then another one means the second one. Okay, so f prime of x, like that. F prime of x. So this means the second derivative. So you can keep on going actually. So it can even go to f prime of x. Like that. It can continue going like that. But our interest is the second derivative, which is given by f prime of x, like that. So we have some examples A, B, and C. By now you should be familiar with how we find derivatives. So if you do not know how to find derivatives, I'm going to link the video. I'm going to link some videos on how to find the derivatives in the description below. Okay, so let's start with question A there. So we have A, alright, y is equal to 2x to the power 3 minus 3x to the power 2, okay, plus 1. And then they want us to find the 2y dx2 and the dy dx squared. Alright, so I'm going to use A, the example question A, to prove a fact. So to find the 2y dx2, the first thing that you do is this. You first start by finding your dy dx. By now you should be familiar. Your answer here would be 6x squared minus, again, 6x. Derivative of the constant is 0. Then again you differentiate this. If you differentiate that with respect to x, you're going to have the 2y dx2 is actually equal to 12x minus 6. So this is your d2y dx2. Alright, and then they're also saying find dy dx squared. Dy dx is this that we found here. So dy dx, which has to be squared, is equal to 6x squared minus 6x. They are saying everything here has to be squared. So let me put this in brackets, okay? Squared. Because they are saying dy dx squared. Alright, by now you should know the expansion of this. 6 squared is 36. X squared is going to be x raised to the power 4. Alright, because they're saying x squared times x squared. Okay, and then here 6x squared multiplied by minus 6x. You're going to have x 36, okay, minus 36x cubed, and then minus 6x, you square it, you're going to have plus 36x squared. So this is your final answer here. Okay, if you can't see it, let me just write it properly. 36x to the power 4 minus 36x cubed plus 36x squared. Alright, that's how you find the 2y x2. We'll cover B and C in later examples. I just wanted us to understand something. That if you want to find the first derivative, first of all, the first derivative, we just do what we know. It's finding your dy dx. But to find the second derivative, which is your d2y dx2. You differentiate your dy dx, and then you're going to have this as your second derivative. Okay, so another thing to note is that dy, alright, so you have seen this answer here and this answer here are not the same. d2y dx2 and dy dx squared, here the answers are not the same. So in conclusion, alright, to conclude the video, in conclusion, d2y dx2 is not equal to dy dx, which has to be squared. So this is not equal to that, and it's not the same thing. Okay? So this means the second derivative, this is something different. So that's one thing I want you to pick from this video, is that the 2y dx2, alright, it is not the same as this. Thank you so much for watching this video. I hope you learned something. Stick around for more videos to come. This has been Cornelius Tubinda with another video, and bye bye.